The final last bit is about water. It's not much, it's a very short segment. Water is obviously H2O. If you don't know that water is H2O, I don't know. I really don't know what to say. That's okay. You can also not know that water is H2O. So simply made up of two H atoms, two hydrogens, and one O atom. Water is a clearly polar compound. Why do you call it that water is polar? We call water as being polar because it has these things known as dipoles. What exactly is a dipole? A dipole can simply be described as being an unequal distribution of charges in a covalent compound. Unequal distribution of charges in a covalent compound. Unequal distribution of charges in a covalent compound. Why do we have this unequal distribution then? That's because water contains oxygen and hydrogen. Oxygen is more electronegative. That is chemistry knowledge. But the idea is that oxygen being more electronegative, he's capable of attracting more electrons than hydrogen. So because of that, the electron density will be near oxygen a little bit more than hydrogen. A little bit more than hydrogen. Therefore, oxygen is going to have more electrons near it. No, therefore it has a negative charge. But we don't usually call this a directly negative charge. That's not the idea. We say that it has a polar negative charge, a slight negative charge. How exactly we're going to represent slightness is using the delta sign. And that is the delta sign. What is delta negative? Sorry, oxygen is delta negative and hydrogen is delta positive. Delta in the sense a little bit, a tiny bit. Oxygen is more electronegative, so it has a delta negative charge. It's closer to negative charged electrons. It can pull electron density from the hydrogens. That's why. I think I should write that down as well. Oxygen is more electronegative. Electronegativity is simply the ability to attract electrons. Let's discuss about 4 important properties of water. This is what makes water such a good solvent. It's one of the main solvents. No, it's even one of the main constituents of our body. But why? Why is it so good? The first thing is it's great as a solvent due to its said polarity. Due to its said polarity. And this you know. Water typically has a very high surface tension. Water typically has a very high surface tension due to the ability of these water molecules to stick to each other. We call that cohesion. Cohesion is where water molecules stick to each other. That's how cohesion works. And this is important. Water also has a very high specific heat capacity. Water has a very high specific heat capacity, meaning it can hold on to a lot of heat. If I'm putting all of that in very simple terms, it can hold on to a lot of heat. It has a high specific heat capacity. Because it can hold on to a lot of heat, it's able to disseminate that heat a lot as well. That's why when we sweat, mostly our sweat is water and salts. Water is taking away most of our body heat. Finally, density. ice is less dense than water. Ice is less dense than water. Therefore, something interesting is that lakes freeze from the top. If lakes freeze from the bottom, that's going to be a huge problem. Lakes freeze from the top because of density. Ice is less dense than water. With that, chapter 2 is concluded. That was biomolecules or biological molecules.